Hello dear students. Next chapter is chemical kinetics. Now, most of the chemical reactions. What do you mean by first chemical reaction? It is a process that is involving in breaking down of the old chemical bonds with the simultaneous formation of the new chemical bonds. Try to understand. Some of the chemical reactions which occurs in nature, either spontaneous or non-spontaneous chemical reactions. Some chemical reactions are very fast reactions. For example, you know the reaction between acid and base. That occurs within a fraction of a second in the range of 10 to the power of minus 14 to 10 to the power of minus 16 seconds. It is very difficult to predict the rate or velocity of the chemical reactions. You studied a little bit about the analysis of the radicals. In the analysis of the chloride ions, you are using the silver nitrate solution. By the addition of the silver nitrate solution to any salt that containing chloride ions, immediately it gives a white precipitate, a curdy white precipitate of the silver chloride. The reaction is very fast, instantaneous. And in the analysis of the acid radical like sulfate ion, you are using a barium chloride solution. Then immediately it gives barium sulfate precipitate. See the precipitation reactions, which is insoluble residue formed during the chemical reaction. Reaction between sodium hydroxide and hydrochloric acid. Reaction between barium chloride and sulfuric acid or any salt containing sulfate ions. Reaction between the silver nitrate and HCl or potassium chloride, whatever it may be. These reactions are very fast reactions. Some of the reactions, for example, the rusting of the iron. It will not take place within a single fraction of minute or fraction of second. If you keep an iron piece in air, longer period it requires to form rust on the surface of the iron article. As the hydrated ferric oxide is formed and deposited over the surface of the iron, it is not involved in the fraction of a second. Where is the sum of the chemical reactions? The reaction between hydrogen and oxygen. At lab temperature it gives suppose water. So many reactions are there. And one more thing that you know. Every day we are using the pressure cookers, refrigerators, and some of the chemical reactions, they occurs in the presence of sunlight. They are photochemical reactions, photosynthesis chemical reactions. Some reactions they occurs during night. There are dark reactions. Where some reactions they are associated with the liberation of the heat energy. Some reactions they absorb the heat energy. Some reactions they place by passing electricity, whereas some reactions they generate electric current during the course of the chemical reactions. Now, why this is due to? Why some reactions are very fast reactions, some reactions are very slow reactions, some reactions are very moderate chemical reactions, and some reactions they liberate energy, some reactions that absorb energy, some reactions that occurs in the presence of sunlight, some reactions they occurs during night, and some reactions they occurs by passing electricity only. They are called electrolysis chemical reactions. Some reactions they generate electric current. Now, usually thermodynamics that you studied in your first PUC that deals how the chemical reactions that are feasible Whether the chemical reaction is feasible or not, that can be explained on the basis of thermodynamics, chemical thermodynamics. And here chemical kinetics that deals with the velocity or rate of the chemical reactions. And also the various steps that are involved in the chemical reactions and some of the factors that influences the velocity or rate of the chemical reactions. Now, what do you mean by chemical kinetics? Chemical kinetics is the branch of the physical chemistry. You know, the physical chemistry is broadly classified into different titles: thermodynamics and thermochemistry, electrochemistry, surface chemistry, chemical kinetics. Whereas some factors are there, whereas the electrochemistry, that electrical energy is the criteria. Thermochemistry, thermal energy is the criteria. Surface chemistry, surface phenomena is the criteria. Chemical kinetics, here the velocity is the criteria. Kinetics means, in Greek word, it is the movement, which is nothing but the mobility or the velocity, and hence the term is called kinetics. Whereas the kinetics here refers to the velocity of the chemical reactions or rate of the chemical reactions. Now, what do you mean by chemical kinetics? Chemical kinetics, it is the branch of physical chemistry. It is the branch of physical chemistry. It is the branch of physical chemistry or in general chemistry. It is the branch of physical chemistry or in general chemistry, deals with the velocity or rate of a chemical reaction, velocity or rate of a chemical reaction, comma, factors influences the velocity or rate of a chemical reaction. Usually factors are nature of the reactant, concentration, temperature, etc. I will discuss in later. And the mechanism of the velocity or rate of the chemical reaction. Is called chemical kinetics. In some cases, it may be simply branch of chemistry also. branch of physical chemistry you have to underline, or you can consider a simply chemistry also. But physical chemistry is a precise word, or you can use chemistry. That deals with the velocity or rate of a chemical reaction. This is very important. And factors influences the velocity or rate of the chemical reaction is important. And the mechanism of the velocity or rate of the chemical reaction is important. Now this is called chemical kinetics. Very important chapter. If you understood the first year equilibrium chapter, chemical equilibrium chapter, then kinetics is so simple. Because equilibrium is classified into two types: chemical equilibrium and ionic equilibrium. Chemical equilibrium is the fundamental for chemical kinetics. Ionic equilibrium is fundamental for electrochemistry. That is why if you not understood the concepts of the chemical equilibrium or ionic equilibrium, better to study first chemical equilibrium and ionic equilibrium chapter, first PUC, and come back to the chemical kinetics chapter. Therefore, knowledge is required from the first PUC level. Is it clear? This is chemical kinetics. You know about the velocity or rate of the chemical reaction. Velocity or rate of the chemical reaction. Velocity or rate of the chemical reaction. Chemical kinetics. Now what do you mean by rate or velocity of the chemical reaction? Rate or velocity of the chemical reaction. Rate or velocity of the chemical reaction. What do you mean by rate or velocity of the chemical reaction? See, whenever the chemical reaction occurs, suppose the reactant or reactants, they gives rise to either product or products. Usually in chemical reaction, reactants react to give the product, means R that gives rise to P. Try to understand. Initially, the concentration of the reactant, assume concentration of the reactant, concentration of the reactant, concentration of the reactant. Usually concentration is expressed in terms of molar concentration. Molar concentration. If it is a gaseous reactant or the gaseous product, concentration is expressed in terms of pressure, like bar pressure or atmospheric pressure, like that. Now initially, assume that concentration of the reactant is 100 moles. Concentration of the reactant is 100 moles. And the product is equal to 0 mole when T is equal to 0. Whenever time is equal to 0, assume the initial concentration of the reactant is 100 mole or 100 unit. The product seems to be 0 when T is equal to 0, means the reaction is not at all started. Assume at certain instant of time, the concentration of the reactant is found to be 90 mole and concentration of the product is found to be 10 mole at an instant of time t, that is equal to 10 minute or 10 second. 10 minute or 10 second. Concentration is expressed in terms of molar concentration, means that is moles per cubic decimeter. That is the unit of molar concentration. That is 100 units. It's 100 units here corresponds to 100 moles per liter. This is now it is 90 moles per liter. This is the unit of concentration in terms of molar concentration. Now at certain stage it may be 100 unit, that is 100 moles per liter. Now this is suppose 20 unit. 20 unit. Now suppose time t is found to be 20 seconds. If suppose that is equal to 70 unit, that is 70 moles per liter, then it is suppose 10 unit, so 30 unit. That is product formed is further increased as time increases. 30 unit. Then suppose time t is equal to 30 seconds. Time t is equal to 30 seconds. It is in terms of second. It is not, that is second. This is in terms of second. This is in terms of second, not capital S, this is small s. That is in terms of second. Now as the reaction proceeds, the concentration of the reactant gradually decreases while the concentration of the product gradually increases. At certain interval of the time t, whereas the molar concentration of the reactant and molar concentration of the product are equal, then that state is called equilibrium state, and hence chemical equilibrium is a dynamic equilibrium, because molar concentration of the reactants and molar concentration of the products are same at this stage, but the reaction not stop at this stage, then the tries to go back to an higher condition and further. Therefore, the equilibrium stage, the chemical reaction is not stopped. Therefore, that is called as a dynamic equilibrium. Dynamic equilibrium. Now here, suppose this is R1, this is R0, means at an instant of time t is equal to. This is suppose R10. After 10 minutes the reactant concentration. Suppose this is equal to R20, means after 20 second the molar concentration of the reactant. This is suppose R30, that is at an instant of time 30 second. Now suppose this is considered as a product. This is equal to product at an instant of time 10 second. This is product at an instant of time, that is 20 second. The product at an instant of time, that is a 30 second. And this is product at an instant of time 0 second. Now see, this is R0 minus R10. This is change in molar concentration. At an interval of the time, that is a T0 difference, that is a T10 difference and T0. T10 difference at T0. Or this is the difference between, like this you have tried, that is the difference between, this is also difference between. That is a T0 difference T10. This is nothing but change in molar concentration of the reactant. Change in concentration, usually that is in molar concentration. Change in concentration of the reactant. Change in concentration of the reactant. Change in concentration of the reactant, usually molar concentration of the reactant, divided by change in time interval, divided by change in time interval, change in time interval, change in time interval. Now see, this is equal to that the difference in the concentration of the reactant. Now what do you mean by the velocity of the chemical reaction? What do you mean by the velocity of the chemical reaction? Velocity or rate of the chemical reaction. That is nothing but change in molar concentration of the reactant per unit time. Or also we can express in terms of change in molar concentration of the product per unit time. Now, especially in case of the liquid reactions or fluid reactions, we are using moles per liter, that is the molar concentration. For gaseous systems, either reactants are gaseous and also products are gaseous, then rate can be expressed in terms of, that is molar concentration is replaced by means of the pressure of the gas. The pressure of the gas means you have to put a unit of the pressure, that is bar pressure, or you can use atmospheric pressure, or you can use Pascal pressure, whatever it may be. Now what is the rate or velocity of the chemical reaction? Rate or velocity of the chemical reaction is defined as change in concentration of the reactant, most precise word, change in molar concentration of the reactant per unit time. It is given by means of rate is equal to change in concentration of the reactant or change in concentration of the product divided by the time interval, what is the time taken by the chemical reaction, time taken by the chemical reaction. Now, how do you define the velocity of the chemical reaction? How do you define the velocity of the chemical reaction? Velocity of the chemical reaction. Rate or velocity of the chemical reaction. Rate or velocity of the chemical reaction. Rate or velocity of the chemical reaction is given by change in molar concentration of the reactant, change in molar concentration of the reactant, change in molar concentration of the reactant, or you can use product also, change in molar concentration of the product divided by time interval or time required to bring about the change. Time required to bring about the change. Time required to bring about the change. Bring about the change. Time required to bring about the change. It is defined as the ratio of change in molar concentration of the reactant or molar concentration of the product to the time required to bring about the change. Now usually the molar concentration is expressed in terms of what? What is the unit of the molar concentration? Unit of molar concentration, unit of molar concentration, unit of molar concentration is moles per liter or moles per cubic decimeter. What is the unit of time? Unit of time is second, in terms of second. Therefore, what is the unit of rate? What is the unit of rate or velocity of the chemical reaction? Unit of rate or velocity of the chemical reaction. Velocity of the rate or velocity of unit of rate or velocity of the chemical reaction. velocity of the chemical reaction is moles, here numerator moles per cubic decimeter, in denominator you have second, that is equal to moles per cubic decimeter per second. This is the unit of velocity or rate of the chemical reaction. If reactants are products, if reactants are products or in gaseous phase, reactants are product in gaseous phase, reactants are product in gaseous phase, then usually the numerator is in molar concentration is under either bar pressure, that is the unit of pressure, bar, unit of pressure, bar pressure divided by second, that is equal to bar second, or it may be equal to atmosphere per second in case of the gaseous system, atmosphere per second or bar per second. This is the unit of velocity or rate of the chemical reaction, velocity or rate of the chemical reaction. Is it clear? Now, what about the rate of types of the chemical reaction? Afterwards, we'll discuss the average and instantaneous velocity of the chemical reaction. Average or instantaneous chemical reactions. Reactions are classified. Reactions are classified into three categories. First type of reactions are fast reactions. Fast or instantaneous reactions. Fast reactions or instantaneous reactions. Here, usually they occurs in 10 to the power of minus 14 to 10 to the power of minus 16 seconds. The completion of the chemical reaction usually occurs. They are very fast reactions or instantaneous chemical reactions. Usually they are ionic reactions. Not usually, they are usually ionic chemical reactions. They are very fast reactions. Ionic reactions means chemical reactions occurs by means of ionic spaces. Chemical reactions occurs by means of ionic species. Example, you know that reaction between sodium hydroxide and hydrochloric acid. Reaction between acid and base. Then it leads to the formation of sodium chloride and water. That is salt and water. The reaction is instantaneous chemical reaction. Very fast reactions. Fast reactions are instantaneous chemical reactions. The second one type of the reactions, slow reactions. Slow reactions. Slow reactions. Now, what are very slow reactions? Give an example. In fast reactions, few more examples are there. For fast reactions, I will give a few more examples. The precipitation reactions. Precipitation reactions. Acid-base reactions and the precipitation reactions. Now, these are acid-base reactions. Acid-base reactions are instantaneous reactions. Acid-base reactions are instantaneous reactions. Acid-base reactions are instantaneous reactions. Now, one more is that precipitation reactions. Precipitation reactions. Precipitation reactions. Precipitation reactions. You know that silver nitrate and HCl reaction. Silver nitrate and HCl reaction. Immediately it gives rise to silver chloride plus HNO3. Silver chloride is insoluble in acid medium. This is a silver chloride. Silver chloride. That is a precipitate. Silver chloride. It is a precipitate. Silver chloride is a precipitate. The reaction is very fast reactions. I will give the hint. We are used this in detection of acid radical. In the detection of acid radical, that already used this precipitation reaction. Precipitation reaction. One more is that precipitation reaction. Reaction between barium chloride and sulfuric acid solution. Barium chloride and sulfuric acid solution. Immediately it gives rise to barium sulfate and HCl. This is precipitate. Barium sulfate is a precipitate. Barium sulfate is a barium sulfate. Barium sulfate is a precipitate. Barium sulfate is a precipitate. Barium sulfate is a precipitate. Now, these reactions are good examples for instantaneous chemical reactions or very fast chemical reactions. All these reactions are good examples for ionic reactions. All these reactions are good examples for ionic reactions. And hence these are instantaneous chemical reaction. The reaction would occur at 10 to the power of minus 14 to 10 to the power of minus 16 seconds. 10 to the power of minus 14 to 10 to the power of minus 16 seconds. In such cases, difficult to predict the rate of the chemical reaction. Difficult to predict the velocity. Difficult to predict the velocity of the chemical reaction. Predict the velocity of the chemical reaction. Velocity of the chemical reaction. Difficult to predict the velocity of the chemical reaction. For ionic reactions, it is very difficult to predict the velocity of the chemical reaction. Good examples for ionic reactions are very fast reactions are reaction between acid and base, that is nucleation chemical reaction, and precipitation reactions are good examples for ionic reactions, and in terms of the fast reactions or instantaneous chemical reaction. Reaction between silver nitrate and HCl to give silver chloride is a good example for instantaneous chemical reaction, and reaction between barium chloride and sulfuric acid to give barium sulfate and HCl. It is both are precipitate. Both are white color precipitate. Both are white precipitate. This is also white color precipitate, white color precipitate. Is it clear? These are fast and or instantaneous chemical reactions. Next one more is a good example, that is a slow reactions. Slow reactions. Slow reactions. Second category of the chemical reactions are slow reactions. Slow reactions. In that good example is rusting of iron. Rusting of iron. Rusting of iron is a slow reaction. They requires days. They requires either days, in terms of days, they requires days, in terms of days. A single day is not sufficient, or fraction of second is not sufficient. Rusting of iron. Whereas iron when exposed to air, iron metal when exposed to air, for example, iron, when it is exposed to air, oxygen part of the air, that takes place in the presence of moisture, that catalyzes the chemical reaction, then it gives rise to Fe2O3, 3H2O. That is called rust. Hydrated ferric oxide. This is called hydrated ferric oxide. Hydrated ferric oxide. Hydrated ferric oxide, that is called rust. The rusting phenomena is not occurs in a fraction of a second. By immediately when you are keeping the iron particle in air, it does not use the rust like that of the reaction between sodium hydroxide and HCl, a reaction between silver nitrate and that is HCl, a reaction between barium chloride and sulfuric acid. They are not instantaneous, they are considered as slow reactions. And one more is that whenever the reaction between rusting of iron, one more is the reaction between carbon monoxide and reaction between carbon monoxide and hydrogen. It forms the methanol. You know that it forms methanol. Then it gives rise to methanol, that is CH. In your first piece you study about the reaction, but at lab temperature, here it does not involve any catalyst, non-catalytic chemical reaction. That is at lab temperature. You know that when you put zinc oxide and chromium sesquioxide at high temperature, then it gives the methanol. That will take place very fast. But whenever the reaction between carbon monoxide and hydrogen at lab temperature, and reaction between hydrogen and oxygen at lab temperature to give water, they are not instantaneous reaction, they require more time, and hence they are considered as slow reactions. Whereas at lab temperature, not on heating, here no condition is maintained. You are not supposed to put any condition on the arrow mark, just at lab temperature, And one more is that reaction between hydrogen and oxygen, reaction between hydrogen and oxygen. You know that H2 plus O2, that is half O2, then it gives rise to H2O. Now this is at lab temperature. When you maintain it under extraordinary condition, then immediately it gives rise to the water. But at lab temperature, it is very difficult to produce water. Therefore, it requires some days. Therefore, these reactions are considered as slow reactions. One more is moderate chemical reactions. Moderate chemical reactions. In terms of hours they requires moderate chemical reactions. The third category of the reactions are considered as moderate chemical reactions. Moderate chemical reactions. Moderate chemical reactions. Moderate here refers to with respect to time, either in terms of second and in terms of minutes they are involving. There is a decomposition of hydrogen peroxide. Decomposition of hydrogen peroxide. Decomposition of hydrogen peroxide. That is H2O2. H2O2. That gives rise to H2O plus O2. Decomposition of hydrogen peroxide and decomposition of nitrogen pentoxide. Decomposition of nitrogen pentoxide N2O5, that on heating it gives rise to NO2 N2O5 plus O. Or if it is a 2 N2O5, then it is a 4 and O2. 4 and O2 balance the chemical reactions. And inversion of the sucrose, that it gives rise to glucose and fructose. Inversion of the cane sugar or sucrose. Inversion of the cane sugar. Inversion of the cane sugar. Cane sugar means that is sucrose. Inversion of the cane sugar means sucrose. That is C12H22O11. Inversion means that is a hydrolysis chemical reaction, acid hydrolysis chemical reaction. Then it gives rise to glucose and fructose. That gives rise to glucose and fructose. That is an example for moderate chemical reaction. Inversion of sucrose, that gives rise to glucose and fructose. It is an example for moderate chemical reactions. And reaction between nitric oxide and chlorine gives nitrosyl chloride. Reaction between nitric oxide, reaction between NO and Cl2. Reaction between nitric oxide and chlorine. Reaction between nitric oxide and chlorine, that is NO plus Cl2, that gives rise to nitrosyl chloride. Nitrosyl chloride. It is a good example for moderate chemical reactions. See that I mentioned so many chemical reactions. Very fast reactions, slow reactions, moderate chemical reactions. In very fast reactions that I mentioned, neutralization reaction and precipitation reactions. In slow reactions that I mentioned, photosynthesis chemical reaction, rusting chemical reaction, and reaction between carbon monoxide and hydrogen to give methanol. Reaction between hydrogen and oxygen to give water. Even photosynthesis chemical reaction is also very slow reactions. In moderate chemical reactions, we have decomposition of the hydrogen peroxide, decomposition of the nitrogen pentoxide, inversion of the cane sugar. Means that is nothing but hydrolysis of the cane sugar. Hydrolysis of the cane sugar. What is the hydrolysis? That is nothing but interaction of the chemical compound with water is called hydrolysis chemical reaction. Interaction of water with chemical compound is called hydrolysis chemical reaction. This is about rate or velocity of the chemical reaction.